Hello, everyone. From everywhere in the world, I see. I'm Agustina Jaime. I'm an industrial designer myself. I'm part of the tech support and training team of McNeil Europe, which we are based in Barcelona. Thank you again for joining us today. One of the rules before I started is that we have the cameras and the microphones off, and you can do any comments or questions through the chat, and I will read them to Peggy at the end of the webinar. We will have around 50 minutes for Q&A, and you can ask any questions, and I will gather them to read them at the end. We have the pleasure to have with us today Peggy, which I've met in Copenhagen, and I loved her work. So I invited her. She's an architect, an artist, and the co-founder of Patchair Design. She spans across physical installations, robotic, and media art. She's based in London, or she practiced in London.
In London, yes.
Perfect. And served as a research assistant at Tongji University College of Design and Innovation in Shanghai. So whenever you're ready, Peggy, thank you again for joining me in the webinar, and thank you for your time.
Thank you, Christina. Thanks again for inviting me to the sharing. And thanks everyone for joining me today. It's really nice to meet you all. I'm Peggy, so I'm an architect and artist and co-founder of Patchair Design. I'm currently working in the intersection of computational art, fabrication, and architecture. So Patchair Design is a studio that focuses on art and furniture. So my background, I studied and graduated from Architecture Association, and I've worked in London for a couple of years. So my practice explore how the computational tools, especially like Rhino Grasshopper I'm going to talk about today, can evolve beyond like generation to become like a system of behaviors. I'm very interested in how like machines can perform, learn, and co-create together with humans. Before diving into the project, I would like to briefly introduce the studio Patch. So Patch is the eco-conscious design studio of art installation and furniture, dedicated to weave together the technology, tradition, and environmental care. Our philosophy is very simple. Design has the power to repair. So now I'm going to show a short video about the studio. So as you see that Patch is a sustainable design studio combining computational design and digital fabrication, and also the background of both of the co-founders of Coastal Village, and also interest in computational design and handcrafting. We're trying to turn the cultural object to more collectible houseware. It is co-founded by Naixing and me in London, in which I focus on computational and robotic fabrication. And Naixing brings deep knowledge of handcrafting and materials. Together that we explore how the digital fabrication can merge with traditional making to tell new ecological stories. We've been really fortunate to showcase our design at Milan Design Week, Salon Satellite, also Design Shanghai. And we showcase once in London Design Festival, and of course in the 3 days of design in Copenhagen. We have also collaborated with many material-based companies, for example, like polymakers, to test 3D printed materials. So through these collaborations, they will assist with material production firms in testing the structural performance and printabilities of their recycled materials through design, in which I'll introduce later. For example, that we experiment with the recycled nylon derived from ocean fish nets developed by polymaker, and also the recycled PET sourced from car waste plastic in collaboration with Convensa. Our design prototype serves as like both a functional application and material performance test. So it helps like manufacturing also to validate new eco materials through creative fabrication. Our design principles aims to reconnect with the elements found in the discarded fishing net, from materials, color, also to a method of weaving itself. We've been traveled to like many coastal cities to study and to learn with traditional weaver and repairing practices. So using this local technique and memories as a source of our design inspirations. Okay, so that's the studio introduction. So through the introduction of 3 projects, I'm gonna talk about how Rhino Grasshopper was used as a tool for us for designing, visualization, and manufacturing. So first, before I talk about the project of Patch, I'm gonna talk a little bit about how Rhino is like the tools for me when I was working as a research assistant in Tongji. The first project I'm going to share is called Robotic Sugar Print, that connects like digital performance, craft, and computation. The work began as part of my research in Shanghai. It explores how the robotic fabrication could reinterpret the traditional Chinese craftsmanship, specifically the ancient street art of sugar painting. The sugar painting has around 400 years old crafting history where the artisan draw like dragons, fish, and different zodiac signs using the melted sugar, of course with hand. So what fascinated us was the precision and rhythm and speed of the hand gesture and how that was making something like both like artistic and edible, and with putting that in parallel with the robotic motion. So we see that if we are trying to question that whether the robot can learn this gesture, whether like the algorithm inherited from the movement of whether algorithm can inherit the movement and emotion of human hands. The work was evolved in 4 different stages. The first was the research and design of the 3D print extruder that was got attached to the robot arm. The second was the sugar print test. I mean the cooking and the printing of the sugar. The third is the pattern design, which we were using Grasshopper, Arduino and Firefly to acquire the sound of the visitors and to transform that into a continuous curve. The last part is the resin fill. In the robotics, in the first part that we were trying to design a custom extruded head for the robotic arm. So at first we tried a few different materials, wood, acrylic, and metal. When we tested, we were trying to test it like if different parameters, for example, the thermal performance, because the melted sugar would get hardened very easily after a cool down. So we have to keep it warm. And also the weight. So the weight of the head has to be proper to be attached and to move. So the first version is a very simple like version that basically without a shell. And then in the second version that we try to design and model a protection shell in Rhino for the head. So basically we measure the dimension and replicate a one-to-one head within Rhino and to 3D print them. But it does improve the heat insulation, but it makes the cleaning and replacement even harder. So in the latest version, like the current version, that we were able to use a enclosed liquid sugar container to achieve the best hygiene and safety. The second step that parallel to the research of that, so we were also testing the sugar syrup preparation and the printing. So after setting up the tool head, due to the valve flexibility, the syrup sometimes would overflow, and also due to the inconsistent line and curvatures, there could be like very hard stop, which create like uneven lines and drips. Initially, it like might seems like a failure, but then it does inspire us to like embrace this imperfection and to experiment with like different drops. However, like despite this, we were also thinking like how can we achieve a very consistent curve with the use of robot arms. So that comes to the third part of pattern making. So at first, we were thinking to draw the inspiration from traditional Chinese motif in Yuanling with the windows. So the robot arms will draw according to the patterns of the windows. And then we moved into a more parametric and generative pattern generation in Grasshopper with the help of Arduino and Firefly. So this allows us to collect and sampling the sound of the visitors and store them. Basically would give us like the pitch of the sound of the visitors in which we could use to create patterns so that each of them will be bespoke for the visitors. Yeah, so basically we're trying to ask whether we are able to achieve a continuous curve and a consistent curvature for the toolpath. In that, so basically we will look the solution, and the solution we were thinking is what is called epicycle. So epicycle is it's basically a Greek. It originated from a Greek astronomy, but then it becomes a geometric concept where the plants was believed to move in circles upon circles, which is a poetic metaphor for rhythm and orbit. So this is one of the examples. Um, what it allows is to have a continuous curve based on a few different parameters. For example, like radius. So the radius of the inner of the main circle, and then the radius of the outer circle, and the angular velocity. So the rotation angles of the planet. Well, the epicycle was approved to be round at the end, but then we were using this mathematic method to draw like lines and to create patterns, basically as a interpretation of the visitor's sound and pitch. So you can see here that basically in Grasshopper that we were able to translate those formulas into, for example, like time slider or like Firefly, like timer. And then Grasshopper was also able to, we're also able to determine like radius, frequency, and phases within the program to create different forms. And you can see here, it's like a graduate change, and then how the robot arms was able to follow the curve. Yeah, in here you can also see that. And then at the end, basically we're able to test like different pitch. We're testing like a series of different pitch with different drawings. And then we're able to record them and then to draw that and like input them back, re-put them back into Kuka Park. So with the help of Grasshopper Kuka Park, that we were able to transform those 2D we're able to transform this 2D like toolpath into like plans and positions for the robot to follow. Yeah, in here you can see that like how we kind of combine different pattern and then ask the robot to follow them like one after the other. So this is a simulation that we're able to create it with Grasshopper Kuka Park. So, well, the first test that we were trying to demonstrate is through a market in a Shanghai creative market. Basically, it's a performance that's live for like 3 days, in which that we were able to bring this setup to the visitors, and to record their sound and be able to present those. And then they were able to either eat it or take it home. Yeah, here's some tests that you can see that we're trying to create both like 2D patterns and 3D patterns because the sugar will get hardened after it cools down. Yes, so I'm gonna play like a 2 minutes videos about the process in animation. Okay, so that was the first project. Nothing too much about furniture, but probably more about robotic performance and interactive art. The second project I'm gonna share is about Patch. So Patchair is the first project I'm gonna talk about. It's a chair that transforms a recycled ocean plastic into minimal forms through a robotic 3D print and also hand weaving. The chair is both a functional object and a symbolic artifact. We were inspired by a discarded fish net from a coastal village. Um, so at the design stage, so basically a Rhino allows us in the designing of the process to sketch as well as to manufacturing the project. So it allows us to control the curvatures and angles with a lot of precision, which is crucial to the furniture's design in this case. So we begin with well, not only 5 iterations, but a lot of like iterations. So we begin with like the massing studies and evolve the design to create like, for example, like like hand-sized openings. So we need to make sure like each of the openings was able to be like went through thoroughly with hand and weaving. That enables like nature weaving. But however, that we realized that some of the openings and also basically from aesthetic and functional view. So it's a lot of like iterative and on and off process. So at the end that we made the first prototype of the chairs. So and Rhino is also a very useful tools for visualizing. And here you can see some examples of how we were using like Rhino Inkscape for quick renders that helps us to imagine the designs of and the colors and the tones of the project. We're also using Inkscape for concept drawings, which allows a very quick visualizing and very straightforward. So well, another part that I'm going to talk about is for the manufacturing. So like what Rhino enables is the precision that helps us to rapidly prototype at 1:50 scale, in which we're able to print from a small 3D printer before we moved into a full-scale manufacturing. The manufacturing workflows of this chair is also done mostly in Kuka Park. So at the first, what we were trying to do is to analyze. Basically, we have after having the base geometry, so we have to contour the geometry based on the layer height of the specific extruder. So we have to slice the 3D material with contour in Z directions. Before we go into the second step of basically dividing the point to evenly and to give sample each curve, use the divide point or like evaluate length to have like small point of control step distance. For each curve that we have to flip the directions for each other curve, like using list. So like at the end, you can see how like this is a simulation you can like we were done in Kuka Park. It's a process that ordered a point to generate the robotic toolpath that we're able to like basically define the speed, layer height, and extrusion like timing with the help of Kuka Park. The translation of Rhino geometry directly into the robot code help us to bridging the design and making. The same like a similar design of the Patchair was used in, for example, this is like when we brought it to the Milan Design Week this year, where it definitely could hold a weight of 2 kids. In this case, this is a smaller version of the chair. So this is the same design that we used to have the collaboration with Polymaker for the first time. So we use this to close this. So we use this to test their material of nylon, which is a lot harder and tougher than other plastic. So it is a material, as a 3D print material they haven't published publicly. So they wanted to like have it tried on the chairs that we make to evaluate the material's printability and strength through different design iterations. Okay. So the fusion of the robotic precision and hand weaving produced works that are both functional and poetic within our studio, that also like kind of bridging the gap between digital fabrication and the design principle that we always trying to carry out. That the design has the power to repair. Okay, so here comes the last project, which is Survase. So this is another project that we have tested together with Polymaker. So we basically we were using the recycled PET that they provided from ocean plastic bottle to like we're trying to keep the original blue tone as a reflection of the sea and the waste. So the making of the form was through rhino grasshopper in kangaroo through a method of differential growth. So basically to simulate the organic form of evolution, allowing the vase to grow like naturally through like attraction, repulsion, and edge length control. At the first, our initial inspiration was to have a vase that has a lot of pores and to have a lot of holes we can put in different things. That was inspired by the fish basket from the coastal village. So this is something that they put the fish in and the water would be able to drip out. So we wanted to basically have similar things, but to put flowers, like fresh and dry flowers. So we find it very interesting. The way we're trying to play with Grasshopper in terms of to design this project is through the differential growth, as I talked about. So the initial so we basically have an initial curve that is going to be the outer lines of the vase. So the kangaroos in this case will only have the curve grow internally instead of externally. If you define the edge of the curve as the edge of the mesh, so we'll only have it to come inside. So at the first we try to like there's a few like important parameters, but there's only two I'm gonna talk about here. The first is the length of the spring. Basically, the shorter it is, the shorter the final length is. You can see here that if we define it as 5, that it wouldn't give it too much length. So like we play with it like to have like some adjustment to like to increase it and to see how the sprinkle would work. Yeah, so this is the process of how it evolved and how that basically constantly grows. The way I likes about it is how that gives you like basically it wouldn't give you the same result every time. Even sometimes if you put the similar parameter, it wouldn't really give you the same result. And also the like a differential growth in terms of here the kangaroo is also very helpful for manufacturing. So the collider basically the collider command will allows you to have a minimal distance between curves and curves at the end of the stage. So like for example, you like so that the printing wouldn't overlap and then it wouldn't be too close. So you can basically input the diameters of the printing head to basically to avoid like overflows and etc. etc. So after getting the 2D curves that we place with it a little bit to see how we can generate forms, objects from those. Yeah, in here you can see like the iteration process of how we basically use like swipe, loft, etc. in like Rhino to create this the vase and print it. So yeah, we were trying to like test different thickness and different materials of the vase. Yeah, it was a really enjoyable process of making this small object of this. Yeah. I mean, so this is like all the project that I shared, I'm gonna share today. So from like edible drawings to like woven ocean plastic to like growing like fossils that I'm trying to kind of see how rhino grasshopper that I've been using for like probably more than 8 years can extend it beyond like as like architecture and like modeling tools to become like a language of performance and art. Yeah, thank you so much for listening. if you like the work and if you like to follow us, you can scan the code to follow us on Instagram and follow the Patch Design on Instagram. And don't hesitate to email us if you have any inquiries and things. Thanks again for Augustina for inviting me. And thanks everyone for listening.
Thank you, Penny. Those very interesting projects that you have, of course. Without a doubt, the chair is my favorite just because I like furniture, I think. But I think your work is beautiful. I mean, patch design is beautiful. If you are ready, I have just a couple of questions. One of them is if did you from let me check the first one from Hannah Campbell for the sugar drawings. How long would it take to print a pattern and have it set, both as a 2D one and a 3D one?
How long is the printing time of one sugar drawing? So it really varies, depends on how you move it. Like basically if you want a thicker line, and you can move the robots a bit slower, that would have a more constant and precise pattern for sure. So I think, but it's actually not long. You can achieve it in a few minutes, like less than 5 minutes.
Does it dry fast?
Yes, it does. It's basically the same as the melted sugar of the old ancient sugar print.
So there's very specific type of recipe, I imagine, necessary. It's not that you can use any type of.
Well, we did add some things at the end, try to make them more stable, but you can create them with just like normal sugars, which is actually less stable to put onto the market or to preserve, I would say.
Okay.
Yeah.
Then I have Michael John Swears. Sorry if I say the last names maybe a little bit wrong. So did you investigate the tools like AI Build or ADA1 at Axis to use more advanced slicing algorithms, for example, non-planars? I know that ADA1 now connects with Grasshopper directly.
Not for this furniture that we make, but for other things for sure. Because this one you can see it, we don't really need to have it to have like nonlinear or angled. But there was project that I work on before in like the previous firm that I work with, which I'm not allowed to share. They were using AI build. So yeah, I did try that, but not in this furniture project. Yeah.
Then I have well, I actually have Timo Kochhoff that is talking about visualization. So he says, if, am I understanding correctly? The visualization is not done in Rhino, but an extra software, Enscape, or is there also a quick slicer visualization in Rhino and Grasshopper? I gave him some information about the physically based ray tracing engine in Rhino, but then he said, my question is mainly what was used for the step from curve toolpath to visualize toolpath render?
To visualize two-path render is entirely done in Grasshopper. Yeah, because there's a lot of tutorials online that how you can animate through the slider in Grasshopper. Basically, yeah, that wasn't done in Inkscape. So the visualizing of the chair, of the color materials was done in Inkscape, and the toolpath was in Grasshopper.
And then I have show Kalke. Okay. The print is continuous base mode, spiraling extrusion without starting and stopping.
Well, it does have to start and stop once, but in the previous example that I shared, yeah, it was basically with like one continuous curve, basically. Yeah.
When did you have to stop? What was the?
So it's one continuous curve with the start and the end at one point, at one single point. Yeah.
Okay. And then last one I have, Jerry George says, hi, can we simulate and check the structural strength of the product?
Can we check and simulate? Yeah, you could definitely do that. But I think basically the point of this design is not about the structural strength, but there's a lot of ways you can do that in Grasshopper, like with Karamba and other like structure simulation tools for sure.
Exactly.
Yeah.
We can mention this in the follow-up email if you want to understand what analyzing tools we have, not only in Rhino and Grasshopper, but also plugins that you can find in Food for Rhino. And then I have one more question of Shaw. In the last project, the basis, is it, well, that was, I think it's the same question. Is it a continuous spiral of plastic extraction, sorry.
In the last project, yes, it is. So because you have to have that to be able to print, because this is not out of robots, so it's out of like 3D printers that we were using. Yeah.
Is the machine Polymaker?
Yeah, we tried a lot. Yeah, we tried Polymaker at first, and then also tried Bamboo Lab, I think, and also I think Polymaker, the material firms they were using, oh, I can't remember, but they were using their like other printing companies like machines.
Okay.
Yeah.
Okay, I think we have no further questions. So thank you so much, everyone, for staying, for listening, and for participating. Again, I'll send you more information to everyone that registered with links. Feel free to contact Peggy at any time if you have any questions or requests, as well as you can contact any of the team in McNeil for any questions about Rhino and Grasshopper. And thank you, Peggy, again for a great presentation and for your time. I hope to collaborate again and see you again.
For sure. Thank you,
Have
Agustina.
a great day, everyone.
Thanks so much for coming, everyone.
Bye.